So, okay, Jai Hind to all. So, today I am here to explain the technique of the virtualization. In previous lecture, we have covered some technique like para virtualization, full virtualization. In this lecture, we will cover hardware assisted virtualization and one more topic, that is the level of virtualization. Okay, level of virtualization. So, let us see the comparison between the full virtualization and para virtualization. So, here we can see with the help of this diagram the comparison of these two. So, in full virtualization, there is the both type of execution, direct execution and the binary translation. This is the binary translation. Okay, guest operating system, critical instructions are trapped by the VMM, then binary code are generated and that are executed on the hardware, and non-critical instructions are directly executed on the system hardware. Okay, but in the case of para virtualization, you can see here direct execution of user request, non-critical instructions are executed directly, similar way just like full virtualization, but critical instructions, for the critical instructions there is the hypercall that is generated at the compile time. Okay, so this is the para virtualized guest operating system kept at ring 0. Difference you can see here. In full virtualization, ring 0 contain VMM, but in the case of para virtualization, ring 0 contain para virtualized guest operating system. Okay, and the virtualization layer kept in the root mode. So, this hypercall to the virtualization layer replace non-virtualized OS instructions. Then hardware assisted virtualization. Hardware assisted virtualization is also called native virtualization, accelerated virtualization, or hardware virtual machines, depending on the vendor. Hardware assisted virtualization is a technology that allow for the CPU instructions set communication in which the VMM run in a new root level mode below the OS kernel level. So, support of this type of virtualization on Intel AMD processors became available in 2006, but was first introduced on the IBM system /370 in 1972. First time this type of concept is used by the IBM in 1972. So, in this type of virtualization, privileged and sensitive calls are set to automatically trap to the hypervisor. The binary translation is not required in full virtualization, just like in full virtualization, or the use of hypercall, just like para virtualization. Okay, so these two technique is not required in hardware assisted virtualization. Hardware assisted virtualization, so it is a way of improving the efficiency of hardware virtualization. It involves employing specially designed CPU and hardware component that help improve the performance of a guest environment. So, this technique is come in picture to provide efficient environment for the virtualization. Okay, so here this is the diagram of this hardware assisted virtualization. Let us see. In this hardware assisted, the VMM is kept in root mode. Okay, root mode, most privileged mode, and all these are kept in non-root mode, less privileged root. Okay, the main difference is that non-critical instructions are directly executed on the hardware, same way just like in para virtualization or full virtualization. Difference is that here OS request trapped to VMM without binary translation or para virtualization. So, here the VMM automatically trap the critical instructions and there is no need of the binary translation and the para virtualization, and that is executed on the hardware level. So let us see the level of virtualization. This is the most important topic, level of virtualization. So basically levels of virtualization means what are the different level in the computer system in computation where the virtualization can be achieved. Okay. So basically there are the 5 levels: instruction set level, ISA level, instruction set architecture level, then HAL, hardware abstraction level, then operating system level, then library or user API level, and finally application levels. That means these virtualization can be achieved at these different levels. That means some may achieve the virtualization at only ISA level. Okay, some may achieve this on only hardware abstraction layer level. Okay, some may achieve on the user application level, some may achieve on the operating system level. So these are the some product that are using this instruction set architecture, like Booch, Cruise, QEMU, Bird. Like hardware, VMware uses this hardware type of virtualization, virtual PC, Denali, Zen. Operating system, there is the jail, virtualized environment, okay, FVM. All these are the product that are using operating system level virtualization. Then Wine, Web, vCUDA, all these are the product architecture that are using library or user level API level virtualization. And the JVM, Java Virtual Machines, okay, .NET CLR, all these are using application level virtualization. Let us see one by one. Instruction set architecture level, what is this? So at the instruction set architecture level, virtualization is performed by emulating a given ISA by the ISA of the host machine. Okay, that means the instructions that are generated by the application, okay, that are emulated in the host machine instruction set architecture. That means the instruction is directly not executed on the hardware. That instructions are emulated in the format of host machine instruction set. Okay. For example, MIPS binary code can run on Cross86 base host machine with the help of ISA emulation. With this approach, it is possible to run a large amount of legacy binary code written for the various processors on any given new hardware host machine. This is the beauty of this particular virtualization, because there are the number of legacy code, okay, that we cannot, this is very difficult to run in present environment, that code. So that code can be virtualized by using the instruction set level architecture. Okay, that means that instructions, legacy code instructions are emulated by the instruction set architecture of the host machine. So the basic emulation method is through code interpretation. So here code interpretation means line by line code translation. Okay, so line by line code of the legacy code are emulated into the instruction set architecture instructions. Other level is the hardware level, abstraction level, that is also known as HAL level, hardware abstraction level. What is this? So at this level, this is performed right on top of the bare hardware. Okay. On the other hand, this approach generates a virtual hardware environment for the virtual machine. For the virtual machine, there the virtualized hardware resources are there. That means hardware resources are virtualized. So basically this is the example that is used by the VMM, virtual machine monitor, and by using the hypervisor on top of the bare hardware. So on the other hand, the process manages the underlying hardware through virtualization. The idea is to virtualize computer resources such as processor, memory, input-output devices. So all these are virtualized. Okay, and thus virtual resource is available for different virtual machine on the same host machine. That means different set of the same physical hardware are virtualized and that is shared among number of virtual machines. So example of this is the IBM VM/370 in 1960s, that is used by the IBM. This type of concept is used by the IBM in 1960s. Next is the operating system level. That means virtualization can also be created at the OS level. So this refers to an abstraction layer between traditional operating system and the user applications. Traditional operating system and the user application. So OS level virtualization create isolated container on a single physical server and the OS instances to utilize the hardware and software in data center. So actually that create a virtualized container between the traditional operating system, okay, and the hardware. The container behave like a real server. OS level virtualization is commonly used in creating virtual hosting environment to allocate hardware resources among a large number of mutually disturbing users. It is also used to lesser extent in consolidating the server hardware by moving services to separate hosts into container of the VMs on the one server. Then the library support levels. So this is the level in which the virtualization is done with the help of APIs. The most application use APIs exported by the user level libraries rather than using lengthy system call by the OS. Since most system provide well documented API such as an interface become another candidate for the virtualization. So virtualization with library interface is possible by the controlling the communication link between application and the rest of the system through the API hooks. The software tool like Wine has implemented this approach to support Windows application on top of Unix host. So this is the library support level. Library support levels means the interfaces, the API and application programming interface. So at that interface, the virtualization is achieved. And at the top of that, all these different stack, there is the user application level. So user application layer means to virtualize the application. That means this is the technique by which you can run the application in isolation. Okay. Just for example, application isolation, application sandboxing or application streaming. All these are the example of this user application level. So virtualization at this application level virtualize an application as a VMs. Okay. On a traditional operating system, an application often run as a process. Okay. So on a traditional computing environment, an application run as a process. Therefore, application level virtualization is also known as process level virtualization. So the most popular approach is to deploy high level language VM. In this scenario, the virtualization layer sits as an application program on top of OS and layer export and abstractions of the VM that can run program written and compiled to a particular abstract machine. Any program written in HLL and compiled for the VM will be able to run on it. The Microsoft.NET, CLR, JVM are the two good examples of this class of VMs. Okay, that means once that particular instruction or applications or process are compiled, that can run on different machine. Okay, that code can run on different platform. So this is the beauty of this user application level. Just like JVM, Java Virtual Machine, that bytecode is generated and bytecode can run on different platform. Okay, that is platform independent. So this is the user level applications. Okay, so thank you. So in this lecture we have covered basically the level of virtualization. So we can create this virtualization at the different 5 level: instruction set architecture level, then at hardware level, then at the operating system level, and then on top of operating system user library level, that is the API also, and then on the top of all these there is the application level, just like application sandboxing, application streaming, application isolation. Okay, thank you to all.